Algebraic expressions are the smallest building block that we really use in maths, and is the key way that we can represent real-world information into something we can actually handle better in maths. Generally, algebraic expressions are split into a few different pieces of increasing difficulty. First is actually representing mathematical information, then ways that we can manipulate information, quadratics, which are a very particular kind of mathematical equation which we use a lot, and this thing called oddness and evenness over here. Representing information can generally be split down further into two different parts. The first is that essentially, as mathematicians, we're lazy. We might want to talk about, however many £1,000 something costs, or we might want to talk about the fact that this requires 20 liters of fluid. But rather than every time writing, £1,000, which takes a while, instead we invent letters which mean this information instead. In the case of pounds, something like this, or in the case of a liter, it would be 30L, meaning liters. And for the most part, we represent these letters as things like X, which is a bit more common to be used in the classroom. But really, this is just the way that we turn things into these letters, and we can then manipulate that using operations. We've spoken about the different operators before in maths, but these are things like addition, multiplication, subtraction, and division, and in more complicated ways, brackets, indices, and other ways that you can do that. We're going to come up with some more complicated examples of this in a minute, but really, most of maths comes down to taking real-world problems and putting them in a way we can understand, and then doing rigid operations to them. The next stage of actually solving these is factorization and multiplication, which are just the various ways that you might want to simplify mathematical problems for obvious reasons. We want things to be simple. And finally, quadratics, which we'll come on to lastly, which is a particular kind of very common mathematical problem, and this is one which very commonly reflects real-life situations. One thing we're not going to have time to get onto today is oddness and evenness. Oddness and evenness just refers to whether a number is even, i.e. it ends in 0, 2, 4, 6, 8, or odd, which ends in 1, 3, 5, 7, 9. This is an important property in maths, but is one that could be quite easily studied by yourself rather than requiring much explanation. To give some examples of representing information for a start, we've got here this apparently enormous drink requiring 5 apples, 2 bananas, and 4 cranberries to be made, expresses information as an algebraic equation. Now, the thing is, you could write this down as a series of instructions and it would be absolutely fine. This is how someone might use it in a bar. But when you're using it in a bar, you're only dealing with small quantities. Say, for example, someone wanted to make 570 drinks because they worked in a warehouse. At that point, it's very difficult to be writing the word apples that many times. So instead, we represent these, and normally we pick a letter. So for apples, we'll pick, I don't know, A, say, and then for bananas, B, and for cranberries, C. So at this point, each of these letters just means apples, bananas, or cranberries. Now, we can make this a step further if we want to and call these X, Y, Z, but for now, this is good enough. We can just call these whatever we want. And what this is basically saying is that if you add these together, because if we mix these together, that means to add them. So introduce operator of addition. We're going to get 1 drink. But we need to make sure we've got the correct quantities of these things. Now, we could write A plus A plus A plus... Well, I've actually run out of room. And that demonstrates right there why we bother to represent the information in a shorthand way. Because rather than writing A 5 times, instead we write 5 in front of A. And this is just a bit of standard notation. This is how we represent this information. 2 for bananas, make sure the color is consistent. And then after that, we end up having the cranberries with 4. And this would be the way you do this calculation. And the reason why we bother to do this is because if, as per previous example, we wanted to have 527 drinks, we know that we just have to multiply everything here by 527. So this is why we bother to represent the information with letters in the first place. It just makes our lives a bit easier. Now, similarly, we might need to mix and match particular quantities and simplify them. So to dilute this drink down for a party, each individual piece of fruit requires a litre of water. How could this be simplified as an equation? So in this case, we've got our same one as before, where we've got this 5A plus 2B plus 4C equals 1 drink. But if we want to dilute it, then we've got to add an additional litre of water for every bit of fruit. There's a few ways that we can actually write this. For example, if we say that a litre of water is represented by W, say, or 1W, depending on preference, you can write 1 in front of the letter or not. So 1W, so that means that in front of all of these, we'd have to write a bracket which contained A plus W, and then B plus W, and C plus W. And the bracket introduces the idea that anything in a bracket is grouped together. So we'd have 5A plus 5W, 2B plus 2W, and 4C plus 4W. Or, alternatively, we know for a fact that there's going to be 5W from here, we know there's going to be 2W from here, and 4W from here, so we could just add those together. And instead we could have 5A plus 2b plus 4c plus, and then we count the number of w's. 4 w's plus 2 w's plus 5 w's is going to make 11 w's, and that'll make one diluted drink. Okay, and that gives you an idea of how you can represent this information. Already, we're introducing so many different mathematical operators, so many of them. This next one uses indices. So much like how previously we said that if you want to add something 5 times, like do 5 apples, we can represent that by saying, okay, that's the equivalent of doing 5 times A. That's where multiplication comes in. What if, instead we wanted to have 5 times 5 and then times by 5? And the way we represent that is using these things called indices. And indices are where we end up getting, for example, in that, 5 with a 2 up top means do 5 times 5. And then if you turn that into a 3, it would then be 5 times 5 times 5, 4, and so on. So this one here says it takes 30 minutes of a culture of bacteria to double in size. Given the culture begins with 1,000 bacteria, write an equation showing how many bacteria there will be after a number of hours h. So we know that we want a number of bacteria, we usually represent with a capital N, and that's going to be equal to our starting number, 1,000, and then that's going to multiply by 2 for every time 30 minutes travels by, which is the equivalent of an hour divided by 2. And that'd be how you'd show this in a mathematical equation. Looks complicated, but this is the way you'd show it. Things like doubling is something that we call exponential growth, and it's actually quite common in things like nature, where you see that the more you have of something, the more it increases by. So that'd be things like populations of bacteria, or number of fruit, and things like that. And if we wanted to make this into an equation to calculate how many bacteria there were after 5 hours, I'm actually going to leave that for you guys to calculate at home, and you can see there's a very big number. Moving on to our next bit. This is now how we multiply things that were actually in brackets already. Now, these are just a few of the techniques that you'd use. This is not based on anything more fundamental. We've already been through that. But in this example, this would be a case of saying if somebody has got this many pounds of something, and this person is going to be given the same number of pounds minus 2, what's the total number? To do that, you might want to multiply these out. In general, when we have brackets, every term in a bracket has to be multiplied by every other term in a bracket. So I tend to start with the x's, and I write them as we go. So we have x times x, which gives us x squared. It's usually good practice when you're multiplying out brackets to have the biggest number of x at the front. By that I mean, if we had x cubed, that would go first. In this case, it's x squared. So next we then have 3 times x, so plus 3x. Then we have minus 2 times x, minus 2x. And then 3 times minus 2. So that's minus 6. Now you may notice the fact that we've then got x squared plus 3x minus 2x minus 6. So we want to simplify these x's. So that then turns into x squared plus x minus 6. And that'd show how we'd simplify this. You may note the fact that we've got a negative number at the end. That's fine. It's very possible to have a positive number here, but a negative number here, just depending on the relative values of the brackets here. Now, when you have got a bigger bracket like this, sometimes there really is no easier way other than just multiplying it out. So we can simplify this one here because it's going to give us a cubic by doing this part first. In this case, it's going to give us x squared plus 3x plus 4x plus 12. And then we can multiply that by 2x plus 5. So I'm going to simplify in this step here. X squared plus 7x plus 12 multiplied by 2x plus 5. And every term needs to be multiplied. So this will tend to create quite a long value. Now, in this case, we're going to end up with x cubed. I always like to start with that. So we have 2x times x squared, which is going to give us 2x cubed. Then we're going to have 7x multiplied by 2x. So that's going to give 14x squared. Then after that, we're going to have 12 times 2x. Now, there's not a particular order you need to pick these in when you've got these. You'll notice I'm just going through each of the first terms in this particular equation. That's fine to do. So that's then plus 24x. Okay, so that's done everything for this 2x component. Now we're going to have plus 5x squared. And after that, we end up getting plus 35x. And there's only one term without x in it, which is then going to be plus 12 times 5, which is 60. Simplifying it down, this then turns into 2x cubed plus 19x squared plus 59x plus 60. So that's quite a mouthful, and you can tell why we want to simplify these values down as much as we possibly can. It's arguable as to whether this is a neater way of writing things in these brackets, or this multiplied out being more useful. I can see it both ways, but it's important to know to be able to go from one to the other. Going from one way to the other involves a process of actually solving these equations, which we call quadratics. At GCSE level, you would not be expected to solve anything higher than a cube. Not only do x cubes not actually appear that much in nature, but they're also quite difficult to solve compared to everything else. So the way that we solve quadratics is by looking at what we just did before and noticing if there are any patterns in the numbers that appeared. So when we did x plus 3 times x minus 2, we may have noted that we ended up with a 3 here and a minus 2 here, exactly the same as these two numbers here, x plus 3, x minus 2. And then the last number was the two of them multiplied together. So what that means is, if we look at, say, x squared plus 7x plus 12, what we're looking for is turning this into two brackets that both have pluses. Now I know these both have pluses because this is a positive number here. And because there's no obvious negative number, they're not going to be both negatives either. And we're looking for numbers in here which add up to equal 7, but that multiply to make 12. Now we can go through the multiple common factors of 12. So MCF of 12 is equal to 1 and 12, 2 and 6, 3 and 4. So it's fairly evident that the ones that will add up to 7 are 3 and 4. And that's how you factorize this. Just listing that multiple common factor method does really seem to be the easiest way. If we go down to this one here, we've changed the letter to y here, but it doesn't mean that we need to change anything else. We're going to turn this into two brackets. Now we notice that this is a positive number, but this is a negative. So what that means is we're going to have two negatives, because those are both going to multiply out to make positive 11. But at the same time, it also means that we're going to be having a negative total number of y's. So we need to think about the common factors of 11. Fortunately, it's a prime number, so it's only 11 and 1. 11, 1. And that's where we get y minus 12. That's where we get minus 12y. And we're going to have the y squared and the plus 11. Finally, we have this somewhat interesting result, which is known as the difference of two squares, very common in maths, which is where we're missing the x part. It might be a bit of a clue, though, if I write for you guys. X squared plus 0x minus 4. So we need two numbers, and we know that one's positive and one's negative, because this is a negative number, that are going to add up to 0. I'll give you a second to try and think of it. And some of you may already know this is x plus 2 and x minus 2, which is where we have the same number, one's a positive, one's a negative, and those are going to cancel out these x's here, and it's also going to make it these multiply to their square number. This is called the difference of two squares, and it's a very important quantity in maths, and it appears quite a lot in simplifying equations. Hopefully you guys enjoyed that video, and it was good to show you through some of the more simplified ways of going through algebraic expressions. These are skills you're going to be building on constantly as you go throughout your maths career, so don't worry if you feel like you don't get it all now. Just try and do some practice for yourselves, and I will speak to you guys next time, so take care.